Welcome to the DIY Honda Garage channel. The DTC P0533 indicates a fault related to the AC pressure sensor circuit, specifically detecting a high voltage situation. The AC pressure sensor plays a crucial role in regulating the air conditioning system by monitoring the refrigerant pressure. This sensor is typically located in the engine compartment, connected to the AC system and the powertrain control module, PCM. When the sensor detects an abnormal high voltage signal, it triggers the Diagnostic Trouble Code P0533. It's vital for technicians to first gather all relevant freeze data and any onboard snapshot prior to engaging in any troubleshooting procedures. This data provides crucial insight into the vehicle's operation just before the fault was recorded, aiding in precise diagnostic capabilities as per manufacturer guidelines. The AC pressure sensor is an integral part of the vehicle's air conditioning system, responsible for measuring the pressure of the refrigerant. Located in the engine compartment, it connects directly to the AC system and the PCM. This allows the sensor to relay real-time data regarding refrigerant levels, which helps in the efficient functioning of the AC unit. When encountering DTC P0533, the sensor is indicating a voltage that is higher than its normal operational threshold. This high voltage could affect the performance of the air conditioning system, leading to suboptimal cooling. A thorough understanding of the sensor's location and function is vital for efficient troubleshooting. The technician must consider that malfunctioning sensors can lead to excessive strain on the AC compressor and other associated components. Hence, it needs timely diagnosis. The possible causes for DTC P0533 can vary, starting with high voltage being supplied to the AC pressure sensor itself. This can arise due to electrical malfunctions or short circuits in the wiring. Another critical factor to investigate is the quality of electrical connections. Poor connections can lead to intermittent readings, creating false diagnostic trouble codes such as P0533. Loose terminals at the sensor or the PCM may also contribute to fluctuating voltage signals, registering high values in the sensor's output. These faults often occur as a result of vibration or corrosion over time. Thus, it's crucial to meticulously check the integrity of all wiring and connections leading to and from the AC pressure sensor during diagnostics. Symptoms associated with DTC P0533 primarily revolve around the air conditioning system's performance. One of the most noticeable signs is the potential inoperativeness of the air conditioning system. Drivers may notice that the air conditioning is not functioning at all or providing inadequate cooling. Additionally, you might observe unusual pressure readings on the climate control system, which could indicate that the AC pressure sensor is malfunctioning. These symptoms can lead to inconsistent interior temperatures, contributing to an uncomfortable driving experience. It is essential to identify these symptoms early to avoid more significant AC system failures or damage. Monitoring voltage anomalies can also provide insight into the electrical issues at play, making it an informative symptom for diagnosis. The first step in troubleshooting DTC P0533 involves starting the engine and allowing it to idle. This initial step is crucial as it gets the vehicle systems operating, allowing for accurate readings from the AC components. After achieving idle, the next action is to turn on the blower switch. This will activate the air circulation within the cabin and engage the AC system. Subsequently, the technician must turn on the AC switch, which will then prompt the AC compressor to activate if operational. These steps set the stage for reviewing the system's current state through diagnostics tools. It's vital to ensure that each component is functioning correctly before proceeding to the next step. Hence, gathering baseline data for effective troubleshooting is essential. In the second step, the technician checks the AC pressure sensor data using the Honda Diagnostic System, HDS. This tool provides real-time data and allows for detailed monitoring of the AC system status. The focus here is on determining the voltage reading from the AC pressure sensor to ensure it is around 4.75 volts or higher. This reading is crucial as it helps establish whether the sensor is functioning properly or if there is a high voltage issue present. If the voltage exceeds the threshold, this indicates that the sensor may be operating correctly, or at least the system is functioning at that moment. However, if the voltage reading is lower than expected, further investigation into the wiring and connections must be conducted to identify possible intermittent failures. Once the AC pressure sensor voltage is checked, the technician needs to determine if the reading is approximately 4.75 volts or more. If the answer is yes, this suggests that the sensor might be functioning normally, and the next step can be approached with just reassurance about sensor integrity. However, if the voltage is lower than expected, it is an indication of potentially deeper issues, such as an intermittent failure. During this phase, checking the wiring connections and ensuring that there are no poor connections or loose terminals at the AC pressure sensor and the powertrain control module, PCM, is imperative. Establishing a solid connection between these components is essential for accurate functionality, as loss in connectivity can often lead to erroneous voltage readings. Solving for any loose terminals can significantly assist in restoring normal AC functioning. In this step, the technician must turn the ignition switch to the lock position to safely work on the AC pressure sensor. The next action involves disconnecting the AC pressure sensor's 3P connector to isolate the sensor from the system. This step is crucial for conducting tests without influencing the rest of the circuit. After disconnecting, the technician should connect a jumper wire between terminals number 2 and number 3 of the AC pressure sensor connector. This jumper wire mimics the pressure sensor's operation and is vital for checking the system's response without the sensor in place. The technique used here allows for pinpointing whether the sensor itself is at fault or if the wiring and connections leading to the sensor are the true culprits. Proper identification at this point is crucial for subsequent troubleshooting and repairs. The next step involves turning the ignition switch to the on position, which activates the electrical systems without starting the engine. This will allow the technician to observe the AC pressure sensor's response under the simulated condition created by the jumper wire. At this juncture, the AC pressure sensor data must be checked again through the HDS. The technician will look for the voltage reading to confirm if it is about 4.75 volts or more. If the voltage meets this condition, it indicates that the circuit is functioning correctly despite the initial fault code. This step effectively isolates the sensor's electrical integrity versus potential wiring issues. In contrast, if the voltage is still below the expected threshold, the technician will need to proceed to further steps to identify issues with the wiring or other electronic control components linked to the AC system. For final repair verification, the technician should ensure all components are reconnected properly after testing and any repairs have been performed. It's essential to clear the diagnostic trouble codes so the system resets and is free of previous fault markers. After clearing the codes, the technician should conduct a test drive to thoroughly monitor the AC performance under real driving conditions. During this period, observing the AC system's functionality is vital to ascertain that the high voltage situation has been resolved and that the air conditioning system operates efficiently. This final assessment ensures that repairs are successful and that the system is functioning as designed, eliminating the risk of future failures. Proper verification not only confirms the immediate fix, but also promotes long-term reliability and user satisfaction. Preventive maintenance is pivotal in avoiding the development of issues like DTC P0533 in the future. Technicians should schedule regular inspections of the AC system, focusing on key components like the AC pressure sensor and associated wiring. A thorough examination of connections and terminals is vital to ensure they remain tight and corrosion-free. As corrosion can lead to voltage inconsistencies, keeping these connections clean and well-maintained should be a priority during regular vehicle service. Additionally, it's crucial to replace any worn or aging components of the AC system promptly. A proactive approach to maintenance greatly enhances the reliability of the vehicle's air conditioning system, ensuring it operates effectively and efficiently for years to come. In conclusion, understanding the role of the AC pressure sensor and its significance within the air conditioning system is critical for timely diagnoses and repairs. The DTC P0533 serves as a warning that requires thorough troubleshooting to maintain optimal vehicle performance. Regular monitoring of sensor readings helps identify issues before they escalate, making it essential for proactive maintenance. In maintaining connections and components, we can avoid failures due to high voltage readings. Continued education on the importance of the AC system in driver comfort cannot be overstated. Ultimately, a keen awareness and systematic approach to diagnosing DTCs will lead to successful repair outcomes and satisfied drivers. Please like and subscribe to the channel. See you next time.